better to start recording and then so that I don't forget. So yeah, just remember that the exam is due this week. So we only have 3 weeks left of the term. Yeah. So this will probably be the only exam on the, well, the practice exam and the real exam will be the only things in the exam category this term. So next term we might have 3 exams, just so you know. But yeah, okay. So make sure you take the exam, and the reason why we're not doing the exam in class is because we just don't have time. We really have to get moving here.
That's fair.
Yeah. So yeah, I think that you'll do fine on the exam. Just do the practice exam beforehand, and you should be fine. The next thing for all of us to remember, if you have not signed up and paid for your AP exam, the deadline was extended, I think, to the 20th of this month. So if you haven't done that, go talk to Ms. Brown, or send her an email. She knows how that works better than I do.
Okay.
Yeah, Elijah?
So I signed up and confirmed with Ms. Brown.
Okay, thank you.
Yep, no problem.
I'm still debating whether to take the AP exam or not, so.
Yeah, you don't have to take the exam, but I would recommend doing it. The only thing that you lose if you don't pass the exam is the $40 to register. If you don't pass it, then that's okay. You'll still get a grade from this class. But if you do pass it, then you get college credit. So I would recommend signing up for it and taking the exam. That's one thing that I wish I had done in my high school career. So I took a bunch of AP classes, but I didn't take any of the exams because no one like sat down and said, you should do this because it can give you college credit. I kind of understood that, but I didn't really understand it. Get what I'm saying? And I was just bad at planning things. And so, but I would recommend doing it. Yeah. And then, yeah, I can't think of anything else that we need to talk about. Oh, so tired. So tired. Okay. So we are moving on to Unit 2. What's that?
Is there a fee required?
I think, okay, so let me read I think it's $40.
Well, no, don't you have to put it down to $40, but then you can pay,
It's $40 if you have like reduced lunch and stuff like that.
Oh, okay.
like, I saw that it was only if you register late, right?
Let me look here. Let me look. So
it's also $40 you only have to pay $40 now, and you can pay the rest later if you're going to pay the full thing.
okay, so I guess it is like a down payment. Yeah, let's see here. The deadline for AP payment / deposit has been extended through October 20th. Please get your payments and deposits into the main office as soon as possible. If you'd like to take the AP exam ordered after this date will incur an additional $40 fee. So yeah, so if you register late, then it's $40 extra.
That's literally as much as it's costing me to take an entire college.
But you know, if the exams this year are.
What, Jeanette?
Would you happen to know if the exams this year are in person or online like we did them last year?
I would assume that they are going to do them online, but I do not know for sure. And the College Board may not even know yet, to be honest. So
I missed that. I like got kicked out for a second.
that decision may not even be made yet. I don't know if they'll be doing it online or if they'll be doing it in person. It's probably just dependent on
Okay.
what is happening in, I think our test is like in March, right? It's in May. You thought it was, so I think it's in March, you think it's in April, and Jane thinks it's in May. Jane knows that it's in May. Okay, you're probably right. Oh, really? Or I might be the first, I don't know, it's one of the two. Let me look here on our syllabus, it has the date.
I think it's July.
Oliver is just being contrarian, as he does. May 7th. May 7th at 8 a.m. Yeah, confidence is everything. You need a 3 to get the college credit. So 1, it's graded from 1 to 3 or 1 to 5. You need a 3.
Like we did last year.
So Jeanette just asked that. I don't know if it's online or not. I don't know if it's going to be in person. They may not even have the decision made yet. Okay. So let me. Okay. So we're moving on to Unit 2. Unit 2, Section 1, so 2.1, which if you have your syllabus, which I don't think any of you do, you can see what that is. So Unit 2.1 is types of chemical bonds. Covalent, ionic, yes. Those are the things that we're going to be learning about today. And you need to have the information from Unit 1 about electronegativity and electron, what's the word? Electron affinity, there it is. Electron affinity for understanding how that works, okay? So if you haven't watched it yet, I recommend watching the daily videos for section 2.1. It's very helpful. So check those out. Someone already highlighted in your textbook? Well, that's nice. It's all pink. Okay. So the two major types of chemical bonds are covalent and ionic, right? So what's the difference between the two? What is the difference between covalent and ionic? We'll get to the reading in a little bit in the textbook. Yes. So that is the gist. So covalent is when an electron is shared, and the easiest way to remember that is that the electron becomes covalent, right? It becomes, so the valence electrons are the electrons in the outer shell, right? In a covalent bond, you have 1 or 2 or 3, it depends on the type of covalent bond. You can have a double covalent bond. That the electron is shared between the valence shells. Okay? So covalent, and I'm going to write this down on Jamboard. And oh, my poor computer doesn't know what to do with its life. Struggles.
I can relate.
What?
I can relate.
Yeah. Okay. So covalent bonds. Oh boy. Oh boy, we're struggling here. All right. So types.
Yeah, the mic starts getting all weird.
Okay, so the two main types are covalent, and ionic. And this has to do with everything about this is about electrons, okay, and how the electrons interact between the atoms and the molecules. Okay, so a covalent bond covalent is when electrons, and I'm just going to put the S in parentheses there, are shared, is /r shared. Okay, that one's pretty straightforward, right? So if we were to make a drawing of this, how would we draw two atoms being covalently bonded?
Share the same outer touches.
So we have a nucleus here. We have a nucleus here. And we have, let's change our colors. Let's go with red. Okay. There's an inner shell. Here's the valence shell. Inner shell. I really tried to make them touch. But they did not touch. It's
It
like,
looks like eyes.
oh, okay. So the outermost electron or electrons are shared. So we can change our color here again. Let's go with yellow. Can we see yellow okay? Kind of. So that's not what I meant to do at all. Jeez. Oh, it just keeps on getting worse and worse. This is so bad. Meh. Quinn will understand. Quinn will say, yeah, Mr. Croshaw is not very good at art. Okay, so you got two electrons there, and then we got a fat electron right here. Yeah, exactly. It's as big as the nucleus.
Only one electron.
Lithium. Yeah. This is two lithiums. Molecular lithium. You see it now? Yeah. Number 3. Okay.
Are there any planets like that where there's like two stars that are nearby each other and there's just a planet sitting there?
So there are planetary and stellar systems that have multiple stars in the center that you can end up with really wonky orbits. You can end up with an orbit if you have two similarly sized stars that orbit each other. You could have a planet that orbits the two stars in a figure 8.
Yeah, but could you have an orbit that doesn't orbit? It just sits in between them?
So in this case, the electron doesn't just sit here. It is going around the nuclei, but it is equally shared between them. So it goes back and forth. So it does like a figure 8.
I thought that was like kind of a false conception of electrons, how they orbit.
Well, it is, but because electrons don't really orbit, they just
I feel like this could be a logo for something.
A
I don't know
logo.
what, but could be.
it could be a logo for something, yeah. You're right, Elijah. That is a misconception that electrons like orbit the nucleus. They don't really orbit. They just kind of occupy space, and that space is a cloud, right? So it's an electron cloud, but this is the easiest way for our little minds to be able to interpret what is actually going on. Okay. So in this case, this is Li2.
Wait, so if there's 2 electrons on the same orbit, it's just a bigger cloud.
Yeah, kind of. Well, it depends on the cloud size depends on the electronegativity and everything that we've been talking about, right? The atomic radius and all that. So yeah. Okay, so covalent bonds, that's pretty straightforward. And this should be just a reminder thing for you for your general chemistry. So in an ionic bond, what happens in ionic bonds?
The electron goes from one orbit to another.
So in an ionic bond, you have the atoms become ionized. That means that electrons are/is stolen. Okay, so that is how does it bond?
Yeah.
So in this, yes, one of the nuclei, we have two nuclei.
Big bad fluoride
Yeah,
or fluorine.
yeah. So we'll do a fluorine.
Picking on little yttrium.
let's do sodium. Let's do sodium fluoride. That is simpler. So sodium is going to have 3 orbits. Boop. Well, it'll actually only have 2 in this case because its shells are full, and that's what it wants, right? It wants its valence shell to be full. How many electrons are going to be in this valence shell? Sodium. Not 11. Why would 11? Come on, man. 8.
I thought only 2 electrons could occupy a shell.
No, only 2 electrons can occupy a sublevel.
Oh, a sublevel. So what's the difference between a shell and a sublevel?
A shell is a shell is essentially what row it is in the periodic table.
Yeah. And a sublevel is like a column.
Sublevel is connected to column, yes, but it isn't the column. The sublevels, so you can have an up and a down, right? Spin, up and a down spin electron in each sublevel. And or in each, anyway, because of the Pauli exclusion principle, right? But in the valence, so if we look at the periodic table, You have, so lithium has 1 electron in its valence shell. Beryllium has 2. Boron has 3. Carbon has 4. Nitrogen has 5. Oxygen has 6. Fluorine has 7. And neon has all 8. So for neon, its valence shell can hold up to 8 electrons, right? What? So we're missing one more because, so this over here, let's do black. This over here is sodium. Okay. This over here is sodium. And this is fluorine. Okay. Fluorine. So
Put the little plus and minus too.
okay, yeah, this is sodium plus. Because why is it plus? Because one of its electrons has been stolen, and therefore it has been ionized. So if we draw this out, fluorine has its inner shell, which has just 2. The innermost shell of every atom only has 2 electrons. And then we have this shell, and this also has 8. But I'm going to do something a little bit different here, okay? We have 1, 2. This is a very square, very rectangular electron orbit, electron shell. 6, 7, but I'm going to do the last one is blue. And why have I put the blue there? It represents an electron. It represents the electron that has been stolen. Okay, so blue represents stolen electron.
Oh,
Does that make sense?
I thought you were trying to represent the electron that's been stolen.
It is.
I mean, by another atom.
So fluorine stole this electron from sodium.
So that means that sodium.
Sodium used to have an outer shell. Sodium used to have an outer shell with just 1.
Oh. I understand.
Does that make sense? So we're going to put a big old X here because it has been stolen. Does that make sense for everybody? So sodium has stolen fluorine has stolen sodium's outermost electron. Why do both of these atoms want this to happen?
So they can cosplay as neon.
So they can cosplay as neon, exactly. Because their greatest desire in life is to be neon. Because it's a noble gas. Everybody wants to be a noble gas. Everybody wants to be a noble gas, okay? Because the noble gases have full valence shells. They have full valence shells because they have a number of protons that aligns with having a full valence shell. Okay? So this is the way that 2 elements can cosplay together as a noble gas. Yep. That is possibly the best explanation that I've heard for that, Oliver, in like modern terms. So thank you.
What noble gas do you want to be, Mr. Crochet?
I am kind of partial to xenon. Anything that starts with an X is pretty cool.
I can agree with that.
Okay, so does this make sense how this works? Atoms are ionized, okay? So when this happens, this becomes F minus. because it only has, so right now we have 10 electrons right here, right? But what number is fluorine? 9, right? So it has 9 protons, 10 electrons. That means that it has a negative charge. Okay, and you can actually do a 1 here, 1 minus, 1 plus. Okay, are we clear on how that works in ionic bonds? Okay, pretty straightforward. Not like the most world-shattering information. I think we're ready for Unit 2 test. Even though we have like a bunch more to go through. All right, so here's what I want you to do. Pull out your laptops. Do you not have your laptop? Get your laptop now. Will do. So what you're going to do is you're going to go to PhET. You can just go to PhET. It's phet.colorado.edu and go to simulations. It's up here at the top. We are going to look specifically, I already have a tab of this open actually, to the molecular polarity PhET simulation. So for those of you at home, pull up another tab with this and play around with it. So you can change your bond dipole so that indicates where your electron is going to go. And so if we do, so this shows that the electron wants to be on this side, right? This arrow. So if we have the electronegativity, so this is a very good representation of sodium fluoride. Yeah, it's in simulations. And then you can just scroll down to molecular polarity. I believe that they're organized alphabetically. So phet.colorado.edu. And you can just, and then you don't have to put in the whole thing, but just navigate to this simulation here. And we can get rid of the electric field, so that gets rid of that. But the electric field there.
So we just have like a bunch of eighth graders. I'm like, hey, let's test student body present.
Oh, hi.
Also, Quinn was sleeping and now she woke up.
Quinn is sleeping.
She was.
I wanted to rotate. I wanted to start spinning. Just go. Can we change the electric field? Oh, we can't. No. So I'll put a link on Canvas, but it's phet.colorado.edu. It's phet.colorado.edu/sims. You can do it with 3 atoms, like this. I'm just gonna make it super complicated. Yeah, for now I just want you to screw around with just the 2, then go to 3.
Oh, so no homework?
Oh, we'll do homework. Suitor wouldn't make us do that. Am I Suitor?
I mean, we did this for the 6 too.
Mm-hmm. Yeah. Okay. So you can kind of screw around with this. Huh? Yeah. So mess around with it for a little bit, and then
Wait, what's a bond
dipole? So the bond dipole indicates where the electron wants to be, or where the negative charge is going to be. Does that make sense?
Yeah.
Uh-huh.
But what's the difference between that and
The molecular dipole is where it wants to be relative to the molecule. This is called molecule polarity. Yeah, just like the two atoms one. Two atoms, molecule polarity. Okay. And you can see if you change the, so if both of our atoms are electronegative, that means that we have a very covalent bond, meaning that they're going to share, right? Does that make sense? Because both of them want it. Both atoms want it. This is what happens when two fluorines bind together. When two fluorines bind together, you get a covalent bond with no charge because the electron is shared equally between the two atoms.
Well, what about like an oxygen atom, say, like the one in the middle?
So
Like,
a CO2.
yeah, the carbon in the middle.
So if we go to real molecules, oh, that's a bummer.
Well, if both the oxygen atoms are like max electronegativity,
So
the one in the middle shouldn't matter.
oxygen, so carbon and oxygen make a double bond between them. That's what happens in CO2. You get two double bonds. So what is happening here? So let's take, for example, fluorine, okay? Or yeah, let's take fluorine as our example because that's the most electronegative atom. Fluorine is sharing the electrons between these two, between themselves, because both of the fluorines want to be a noble gas. And if they share the electron, they can kind of pretend that they are noble gas half the time. Does that make sense?
Hey, Crochet, I think you can click and drag it in circles.
I know, but I want it to just do it on its own.
Well, yeah, but then you can make one more electronegative.
But you can't make it spin.
You can make one barely more electronegative and it'll spin really slowly.
Really?
Yep.
Aha. But it doesn't have momentum. That's what bothers me, is it doesn't have momentum. Like I want it to.
You want it to spin like a helicopter.
Right, if you switch to the 3-particle version, you can control the angles too. And I don't think that those, yeah, that's like a spectrum. So you can make one barely more angled one way. Oh wait, but no, then they don't have the.
They don't have the electric field.
Wait, yeah, they do. You can turn it on.
But I can't make it spin still. I want to like make a molecular machine. That's what I want to do. I want to be able to flip the electric field on and off and have it spin. Okay. So I want you to mess around with this for a minute. I'm actually going to stop the recording here for you YouTube people. Mess around with this. For those of us who are live in class, mess around. I'm going to give you 5 minutes. See what you can learn from this simulation. Okay? 5 minutes. Go.